In this video, I'd like to continue talking about trig identities from reflections and rotations. And for these example problems, we will be on the unit circle, where we have some angle theta measured positively going in the counterclockwise direction. And at a point on this circle, the x and y coordinate would be the cosine of the angle for the x value and the sine of the angle for the y value. And we need to consider what happens when we add pi to the angle in terms of the cosine value. So we're looking at the x value here. And we also need to look at what happens when we look at the opposite of theta. We can rewrite this as cosine of minus theta. And we add 2 pi to that. We want to see what happens to that x value. So essentially, we're looking at this x value right here, which we can see is 0.83 for this particular angle. And we need to compare that to the cosine of these angles here. And for this first one, we are looking at the cosine of pi plus theta. And we can take our angle and then add pi radians to that. And if we add pi radians, that will take us 180 degrees, bringing us roughly over here. And we can draw in a ray going from the origin to a point on the unit circle. And if we draw it correctly, it should form a straight line between these two rays, since this angle is pi radians or 180 degrees. So at this point over here, the x value is the cosine of theta plus pi radians, and the y value is the sine of theta plus pi radians. Let me write that down here. The sine of theta plus pi radians. And if we look at its x value, we can see that would be right here. And if we compare the two x values, it looks like adding pi radians or 180 degrees brings us to the exact opposite x value, meaning that the value of this expression would be the opposite of the x value here, or minus 0.83. If we add pi radians to the cosine function, we get back the opposite value, meaning that this expression here is simply equal to the negative of the cosine of the angle. Now from here, we want to consider this angle, 2 pi minus theta, or negative theta plus 2 pi. And we need to look at negative theta on this graph. If we go in the counterclockwise direction, we are measuring positively to this angle, but we want to go in the clockwise direction, so we measure negatively, and we want to go the same distance around. So we will end up roughly over here. And one way to tell you're doing this correctly is that it should end up on a ray right about here or so, where this angle here and this angle here, these will be equal to each other, meaning that cosine of negative theta should be symmetric to the cosine of theta. And we can mark in that this is the cosine of negative theta. This angle right here is negative theta. Excuse me, this actually goes from the positive x-axis. We're just counting in the clockwise direction. And the y value would be the sine of negative theta. And what we can see is that at negative theta, notice that the x value would be the same as the cosine of theta. And we have derived that in a previous video, but if we plug in negative theta to the cosine function, we just get back the cosine of theta, the original function. And this is the property of an even function in terms of its symmetry. If we look at the graph of this function, we would see that it is symmetric about the y-axis, which is typical of all even functions. And for this problem, we need to add 2 pi radians to this negative theta. And if we're at negative theta, this angle right here, we add in the positive direction 2 pi radians, and we go back to exactly where we are, meaning that adding 2 pi radians didn't actually change the angle. And that is generally true. If we take some angle and we add multiples of 2 pi. We can do it as many times as we want. We just get back the angle. And k here is just a whole number. It's an integer. Could be negative as well. But this would be true if the angle was the opposite of theta. We could add as many times as we want 2 pi radians or 360 degrees, and we'll just get back the angle that we started with. So in other words, the cosine of minus theta plus 2 pi, or 2 pi minus theta, this is just the cosine of minus theta, and we know the cosine of minus theta is just equal to the cosine of theta. And again, that's just because when we compare the two, their x values on the unit circle are equal to each other. So the value of this expression, the cosine of 2 pi minus theta, would just be the x value for the cosine of theta, or 0.83.